Good afternoon, everyone. Welcome to our afternoon session. Noah Kantrowitz, our next speaker, has been active in the Python community for many years. His projects include Track, One Lap per Child, and Python packaging. His experience led him to Chef and now to Balance, where he's a software engineer, and he's also the operations lead for the Python Software Foundation. He's here today to talk about Python packaging and how the future will be better.
No, that's tomorrow.
He's here to talk about application deployment, and tomorrow he will be talking about Python packaging and how the future will be better. So make sure to catch him there too. Please give him a very warm welcome.
All right, thank you very much. Like she said, I'm here to talk about a quick overview of the state of the onion for application deployment. This will mostly be covering Python applications, but generally applicable. So first, a little bit about me. Like she said, I'm the operations lead for the Python Software Foundation, and I'm also one of the organizers for PyCon. By day, I work for Balanced Payments, which does marketplace payment and transaction processing, and I mostly work in the Chef community, doing operations and server automation. And I really, really like making things, which is what led me into all of this application deployment stuff. So a quick overview, what is an application platform? So this term is often thrown around a lot in the context of platform as a service, but what is it outside of as a service? The idea of an application platform is it's a thing that you run your applications on top of. So this is composed of a lot of individual pieces, things like a database, a web server, the configuration files, some kind of orchestration layer, and your application code itself. One thing that is not part of this is the application how you write the application. So I will not be discussing web frameworks or ORMs. This is about deploying whatever it is that you wrote. I will do my best to illustrate the trade-offs between tools, but this is not an unopinionated talk, and I will definitely describe my personal opinions about some of these tools. If that offends anybody, I apologize. So let's first talk about application code. So this is, you have to actually get the bits to the server. You wrote some files, and those files need to be in a place. We don't necessarily care how that happens, but we want to be able to move them around. So the simplest way to do this is tar. Make a tarball on your laptop, copy a tarball to a server, and unpack it. This is very, very simple. This is installed on every machine on the face of the planet, but it's very repetitive, so you'll probably want to build some tooling around it. Usually after that, the next thing people try, if they realize that tar is maybe a little bit unpleasant to work with, is rsync. Same idea, you're going from your laptop, saying whatever is on my laptop, put it onto the server, but it's using an efficient binary transport. Unfortunately, rsync has a lot of very complicated configuration options, and you can end up with very, very long command lines. So again, you'll want to build tooling around it if you're using rsync. Usually the next tool after that people try, this is a fairly linear progression, is to use Git. This also applies to Mercurial, but the idea of use your source control tool as your deployment tool. So moving the code from your laptop up to a server, and then from your deployment machine, pulling down from your source control server, be that GitHub or something else. This is very convenient because it gives you a single point of truth, that the source control server is the current thing that you are deploying, instead of using your laptop, which is very error prone. Another option are to use packages, Debian packages or RPMs or whatever the native packaging is for your system. So this is very similar to the tar approach of take a build of a thing on a system, put it into a package, put the package somewhere, and then install that package onto machines. You get whatever it is that you had when you went in. This is somewhat nicer than tar because most packaging systems like apt and yum have an idea of a repository where you can have linearized versions. So they have a version number associated with them. There's an idea of which one is greater than another one, so you can build upgrade paths over time. These are also nicer sometimes than Git. Git requires a fairly complex server, be it running GitHub or running your own Git serving system, whereas package repositories can be just an HTTP server. I run mine off of S3, for example. And a quick shout out related to building packages for deployment, which is my preferred way of doing application deployment right now. I'm looking to a tool called Omnibus. It's similar to something like Homebrew, where you're building a definition for a piece of software, but whereas Homebrew just installs it onto your Mac, Omnibus actually builds RPMs or debs or any other type of package you want, so it's a very easy way to get started building packages. On to configuration management. So we have some application code on a machine. We need to give it a config file. What exactly goes in that config file varies wildly depending on the application. Sometimes all you need to do is configure the IP of its MySQL server. Sometimes you need to give it a complex set of business logic that varies depending on the customer. So how are we going to manage that? Simplest way, again, to start with, flat files. Just take a file, name it production.py, and check it into your source control repository. This is incredibly simple. It is very readable. It's very clear to your entire team what is being deployed everywhere. It is also exceedingly inflexible. Whatever you have in source control is what your config is going to be. And while this is very nice for readability and versioning, it is not nice for having a lot of variations. And applications generally have a lot of weird special cases. You deploy a staging version and it needs a different SQL server, or you deploy a version for a special customer that needs to use their email system, whatever it is. So this can rapidly become a little bit unfortunate. Chef, like I said, is the one that I know the best, so big disclaimer, it's what I use on a daily basis and what I work on. It is Ruby-based, although quick aside, please don't select tools based on the language they are written in. I'm aware everyone here likes Python, but let's try to leave the tribalism aside. Sometimes the best tools are written in C, sometimes they're written in Ruby, sometimes they're written in PHP. Chef is declarative-ish. It doesn't use a fully declarative syntax, but it's mostly declarative. And it also has a very big ecosystem of third-party tools and integrations. Puppet is another option. Unlike Chef, which uses a Ruby DSL, Puppet uses a fully custom declarative DSL, but it's otherwise relatively similar. It has a very big ecosystem. It's been around for a little while. SaltStack is a second wave system, so it was created after Chef and Puppet. It uses YAML and Jinja as its language of authoring. It's still somewhat smaller than Chef and Puppet, but it's growing very rapidly. And Ansible is the newest of the bunch, and it is growing extremely quickly. It's, I think, currently the third fastest growing project on GitHub. So very, very new, doesn't have nearly the level of integration with external services as the other three, but it has some interesting features. Notably, it's agentless operation mode, whereas the others require you to actually install something on the machine to run your configuration management. Ansible can actually run from your laptop against a target server the same way you do a tar or a rsync-based deployment, and that can be very useful. Unfortunately, it can also be very painful when you have a large number of servers, so I'd only recommend that you look into specifically agent mode, and really Ansible in general in a lot of cases, if you have under 10 servers. So what else do we need to deal with for configuration management? So that's writing the config file. But we need to do some other things, usually creating users and creating service definitions in something like Upstart or Supervisor D or System D. And that's another place where you'd probably want to look at using your configuration management system. If you're using a convergence-based code deployment system, you can run that through your config management, but some people prefer to keep the config management and the code deployment as separate tools for better control. One thing to be aware of is also overusing config management for tasks that really shouldn't be there. Notably, database migrations probably should not be run from your Chef or Ansible scripts. But that leads us into something called orchestration. So what is orchestration? Orchestration is the idea of I have a lot of different servers and I need to run something on some subset of them. Now that command might be as simple as sudo chef client, but it might also be things like running database migrations or activating or deactivating services, things like that. All of this is the idea of running commands in a structured way, preferably in a repeatable way. The simplest of these is SSH in a for loop. You get out bash or your shell language of choice, and you write a for loop that SSHs to a bunch of machines. This is incredibly simple, and it's really not very useful, mostly because you can't build anything that, say, gets feedback from one step. You have to deal with transferring the script files manually. Generally, it's a big mess. I should note Chef does ship this as their official orchestration solution at the moment in the form of knife SSH. So a lot of people here will be familiar with Fabric. Fabric is an orchestration tool. It's written in Python. It uses a Python DSL-y thing for configuring tasks. It uses a parallel execution mode if you would like, which helps speed up execution of all of your machines. If you don't want to run them one at a time, you can run them all in parallel. It also allows multi-tier deployments if you use the execute helper within it, so you can have one task that calls other tasks that get kicked off on different machines. Again, very powerful. And somewhat less useful is the Ansible ad hoc mode. If you are using Ansible as your config management system, it can be very convenient. Ansible ships its own orchestration layer. The two don't have to be used together. You could use Fabric and Ansible, or you could use Ansible and Chef. These are all completely valid options. Ansible's orchestration system does allow some limited ad hoc commands, but it's mostly built around running Ansible playbooks. It also contains something called accelerated mode, which allows you to run multiple commands multiplexed over a single SSH connection. SaltStack also ships its own orchestration tool built in. Unlike the previous ones we've mentioned, which are based around SSH, SaltStack actually uses a 0MQ custom command distribution layer. This can be very convenient and necessary if you have, say, 1,000 servers, which I'm sure not many people here do. I certainly don't. But when you have a lot of servers, the actual time it takes to open an SSH connection to them and the CPU overhead of that can get to be prohibitive. So using 0MQ helps to sidestep that. They have a much lower overhead protocol. This does require the use of the SaltStack master and minion system, whereas you can use SaltStack as a configuration management system without a master, but the orchestration tool requires the minion system. It also has very, very limited ad hoc command running. You can do it, but you generally have to write the modules yourself. So it's mostly, again, useful if you're using SaltStack as your config management layer. Another option is MCollective. So whereas SaltStack used 0MQ, this one actually uses a full AMQP system for its command distribution, which means you have to run a RabbitMQ or ActiveMQ server. But this can be very useful if you have a very, very large number of servers and say you are worried about failures during deploys, things like that. You can build a very reliable system. But it does have very, very limited ad hoc command execution. So again, mostly useful if you are using this. This comes with Puppet. So if you're using Puppet as your config management system, you can use MCollective very effectively as your orchestration layer. It does very conveniently support its own active discovery system. So if you have a lot of machines that are coming and going, that can confuse some things in Salt. MCollective can deal with that a lot better. And a final tool that you can use is called Rundeck. So whereas all the previous ones have basically been command line tools, so you open up a terminal on your laptop and you type something in, Rundeck is actually a service. So you run it on a machine. It's very, very similar to Jenkins in this respect. You put in job definitions of some kind, and then you can run them either through their web interface or through an API or through a command line client. The benefit of this over a command line tool is the same idea of Jenkins versus running your tests locally. It puts it all in one place. It means everyone can see all the output. It means that there's visibility and centralization and accountability over everything that's going on. Also adds things like ACLs, access control policies, stuff like that. I would heavily recommend that you look into Rundeck. I think it is a vastly underutilized tool at the moment. And a final thing, this isn't really a single tool, but more of an idea of Chatops. Once you have something like Rundeck, so your orchestration and your management stuff is all in a service, which has an API, which, say, Fabric doesn't of its own, that means that you can have an IRC or XMPP or HipChat or Slack or whatever else you use. You can have a bot that sits there and will run these workflow commands on request. This has been very popularized by GitHub, and I think this is a really, really important trend, and I think everyone should keep an eye on it. It allows much better visibility within the team of when deploys are happening. It allows non-technical people to do deploys much easier. If your designer cannot deploy your website, you should consider that a bug. So let's move on to databases. So what is a database? A database is where the state of your application lives, whereas your web servers, which we'll get to in a moment, are generally considered stateless. So you can destroy them at will and spin up new ones, whatever you need. The database actually contains information. It contains the state of your application, things like user logins or page content, things like that. Postgres is by far, I'd say, the most popular database in the Python community, and not without good reason. It is an incredibly powerful database. It's highly relational, so it uses SQL as its query and its data description language. It's fully ACID compliant. I won't even get into what that means, but you probably know already. And it has add-ons galore, things like JSON fields or PostGIS, all these sort of community tools that make Postgres much more flexible than sort of you would think a stock SQL database would be. After that, we have MySQL, probably the second most commonly used one, and I am not a fan. It is mostly ACID, notably DDL commands, things like changing tables are not transactionally safe. This means if there is ever an error during your deployment and you are running a migration, you are now screwed. You cannot roll back those changes, so you better continue finishing your deployment somehow, by hand usually. Also, a recent problem in MySQL, Oracle taking over from Sun has led to a lot of community fracturing. So Oracle continues to run the official MySQL project. However, several forks have arisen of recent. MariaDB is probably the most popular of them. It's actually now shipping in Fedora Core Linux as the official MySQL replacement. But there's also things like Drizzle, which is another community-run fork, and Percona Server, which is a corporate-run fork that offers commercial support. I would be very wary of getting started with a new project in MySQL at this point, given the current community fracturing. So from there, we go into the NoSQL world. NoSQL is a really unhelpful term because defining something by way of what it is not doesn't really tell you anything. There are a lot of things that are SQL, but there's a lot of things that are not SQL. Fishes, for instance, are not SQL, but still. Anyway. The first one we'll talk about is Redis. A lot of you have probably used Redis. It is a key value store. It runs entirely out of memory. It has some HA characteristics, whereas Postgres and MySQL have very well-established replication stuff, so much so that I probably don't even need to describe them to you. Redis really doesn't. You have to presume that Redis will fail in the case of network partitions. Redis is incredibly powerful. I like Redis if you are using it in a way that assumes that it's actually a cache, that when the server goes down, all data will be deleted and you have to regenerate it out of somewhere else. If you try to use Redis as a database, it will burn you. Also in the NoSQL world is Cassandra. So Cassandra is a distributed database. It comes from the ancestry of the Dynamo paper. It uses a model called Bigtable, which is basically just very partitionable, the equivalent of SQL tables, but partitionable across multiple servers. You use a query language called CQL, which will be very familiar to anyone that's used SQL before. So you can really jump into Cassandra very easily. Another popular option is Riak. Again, distributed, came from the same original research paper called Dynamo. Instead of using the CQL custom language, it uses a bunch of different indexing options like secondary indexes, Solr compatible search, and MapReduce. But an important difference between Riak and Cassandra, in Cassandra, when you have a distributed failure of some kind, the last write always wins. This is called last write wins, is the model. It means that whoever got the final timestamp is the write that succeeds. This can be disastrous if that wasn't actually what you wanted. Usually what you want is to somehow do the equivalent of a git fork and then a git merge to recombine your data on the either side of the failure. This is possible with something called a CRDT, that stands for Commutative Replicated Data Type, and I will just call them CRDTs because that's a much easier word. But they allow you to do exactly that kind of data merging, and Riak is the only database I know of that exposes this all the way out to the user, allowing you to write your own CRDT types. They are definitely not easy to write. You will get very used to reading academic CS papers if you try to go down this route, but it does allow true high availability with 100% uptime. And I will briefly mention MongoDB and CouchDB and Couchbase. They are also quite popular. Basically, of these three, I would pick the third. Take that as you will. And a quick shout out to Zookeeper. It is a highly specialized database. You would not use this as a replacement for any of the other ones I've mentioned. It offers very strong consistency in distributed environment by using the Paxos family of algorithms. The downside of that is it's very slow. This is designed for configuration and state information about the status of your network. So small pieces of information like who is the current Postgres leader. It allows you to manage that information across your whole network in a consistent way. Onwards to web servers. So a lot of you have probably run web servers. I would say most likely most of you have run web servers at one point or another. They are the thing that actually manages your HTTP requests. They listen on a socket, they take your HTTP request, they do some stuff, they call your application does some stuff, and then eventually some stuff ends up back on a socket. That's the sort of general idea. They may also handle serving your static assets, although that can be handled externally. So most people, when they think web server, they will probably start with Apache. It is the oldest, second oldest piece of software that I've mentioned today, next only to tar. It is incredibly battle tested. This thing has withstood more bizarre, crazy attacks and bugs and everything over the years compared to anything else. Unfortunately, the default configs for Apache are terrible in almost every distribution. You have to take great care when you configure what's called an MPM, the message passing module. That's what determines how it actually serves requests internally. Does it use processes or threads or pre-forking, all that sort of stuff. You have to tune that very carefully, and you won't get a whole lot of help from the defaults in, say, Ubuntu or CentOS. One of the nice things, however, is you get Uwsgi, which is an incredibly flexible application container for Uwsgi servers and allows you to run both your static app, your static file serving, and your Uwsgi app inside a single web server, and that's quite nice. So after Apache, most people will think Nginx. Nginx is newer than Apache, but still extremely battle tested. Most people think of Nginx as faster than Apache. I don't actually think that's very fair. I will also note that the speed of your web server is almost never going to be a bottleneck. Unless you are running an Alexa top 100 website, you really shouldn't care about that. Nginx does have a lot nicer stuff for dealing with reverse proxy. So if you are running some kind of tier of web servers and then dynamic application servers behind it, Nginx is much nicer for that. Just it has a much simpler configuration system for that. Gunicorn is a pure Python application server, so you generally wouldn't use this for serving your static content, but it's usually where people will start when they're serving their Python applications. It's very simple, it's fast, it's pure Python, so you can install it along with all of your other libraries. It's a great place to get started. I will add, you should never expose Gunicorn directly to the internet. You should always run it behind Apache or Nginx, otherwise you put yourself at risk for DOS attacks. Uwsgi is also quite popular. Again, it's an application container, so you only run your Python application in it. It is a C extension instead of being pure Python, so it has a lot more features for integration with stuff like systemd or other third-party tools. Downside, it is very difficult to configure, and the documentation is almost useless. Twisted, this one people probably have not used nearly as much, and you really should. So Twisted has a Uwsgi server built into it. It is extremely fast, and most importantly, it allows you to run Uwsgi apps next to things that aren't Uwsgi apps. This is increasingly important as more and more people are playing with things like WebSockets and other streaming protocols. Then you can run them together, and that can be very, very useful. Downside, not a lot of people use this, so you won't find nearly as many guides, and it can be a little bit complicated to get started. And finally, CDNs, not really in the same category, but pretty close. You should probably look into a CDN for serving your static files. I will give a shout out for Fastly. They are a PSF sponsor and have greatly helped us. But CloudFront is also an option if you are using Amazon or S3 for your file hosting, or you can look at running Varnish yourself. CDNs help accelerate by caching things, possibly in one place, but Fastly and CloudFront have servers all over the world. So server provisioning, I gotta go really quickly. Server provisioning is the tooling that helps you actually boot servers. Now, if you are very unlucky, the server provisioning might be you call Dell, you give them a very large check, and 6 weeks later some metal shows up in a loading dock. Fortunately, most people don't have to do that anymore, so we use the cloud, because yay clouds. That means that you need some way to actually manage all these virtual machines that you're spinning up on Amazon or Rackspace or wherever. The simplest way to do that is manually. Tools like Knife EC2 or Nova Client, or just manually going to their web consoles because they all have them, and create the servers that you need. If you only need 2 or 3 servers, this is probably fine. Downside, if something fails at 4 in the morning, you have to get out of bed and fix it because you are the API. So Amazon has a tool called autoscaling groups. They are unfortunately really specific to Amazon, so super mega vendor lock-in, and you have to drink a lot of Amazon Kool-Aid to use them correctly. But if you have a simple thing like a web application tier, they can be very nice. They will handle detecting that your load average has gone up. They're going to spin up more servers for you. When the load average goes down, they will kill the machines. Super simple to get started with. However, if that wasn't enough Kool-Aid for you, Amazon has a tool called CloudFormation. It takes the same general idea of applying a declarative model to your entire infrastructure. So instead of just creating your web servers, this can help create your database servers and your networks and your routers and everything. It's very fragile, but it's also very powerful. So I would check it out. Heat is just a direct port of CloudFormation to OpenStack. It does offer a YAML format instead of JSON, but other than that, it's basically exactly the same thing as CloudFormation. I will briefly mention RightScale. They offer similar services, but they will run cross-cloud. So if you are a company that is running in multiple different cloud providers, RightScale can be very interesting for provisioning management. Unfortunately, they're very expensive, which is why I've never used them. And Asgard is not quite in the same category as any of the rest of those. It was built by Netflix and is how they run applications internally. So it helps manage doing deployments using Amazon autoscaling groups. All I can say is go check it out. It's very interesting. I'm not sure if it's usable yet. It's still very Netflixy, but it's definitely worth taking a look at how they manage doing new versions and then rollbacks if they need to, things like that. So quickly mentioning secrets management. So secrets management is this idea that in most of your configuration, the data could effectively be public. In most cases, it is. Things like the from address on your emails. No one cares who knows that. Everyone that gets an email is going to know it. But some stuff is different. Some stuff is like database passwords. You need to keep that secret from sometimes from the public and sometimes from servers within your network. So this leads to this idea of how do we manage secret data? The simplest way, use the same thing you use for your configs. All of your existing tools work, it's versioned, and it's woefully insecure because probably anyone that can see your Git can see your database password. Do not push this to GitHub. A lot of people do that. So most people think, okay, I need to encrypt stuff. So encryption is cool. Unfortunately, a lot of people see the word encryption and their brain turns off. Just because it says encryption doesn't mean you're getting any actual security out of it. This includes Chef encrypted data bags and the Ansible Vault system released in Ansible 1.5. I would consider this unwise. Make sure that you understand what guarantees you are getting out of your encryption. For example, with Chef encrypted data bags, you have no easy way of keeping secrets within the network. All of the servers can see all of the secrets. The only thing that it's secret from is the chef server. And if you're running that yourself, you have not actually accomplished anything. So one option for this, and this is the one I use, is to use S3, a private S3 bucket, IAM roles, and the IAM permissions system. Again, super mega Kool-Aid. This is 100% Amazon vendor lock-in, but if you're already all running on Amazon, I would heavily recommend looking into it. The idea is to use a private S3 bucket combined with EC2 server roles, and then authorizing those roles to access specific folders or specific buckets of secret data, and then they can just use any HTTP client to download them. I say you should look into it because of the ones I'm listing, this is the only one that is probably usable and safe right now. This lets you actually keep secret data secret. Barbican is a very new service. It's being developed mostly by Rackspace. It's OpenStack-ish, so it's being developed for OpenStack, but there's no reason you can't use it for something completely unrelated to OpenStack. I would classify it as promising. I'm hoping that I can replace my S3 and IAM mess with this, but it's still very, very young. The API is still being developed, but check it out. Another very new project is called Red October. This was built by the Cloudflare team. It uses what's called N of M secret storage, which means that if you have M people, any N of them can access the secret. So if you have 5 operations engineers, you give them all keys, and then any 3 of them can access the stuff. Unlike the others I've mentioned, which are for online secrets, this is really best for offline or cold secrets, things that are not frequently accessed and don't need to be accessed without human intervention. So for example, the master password to your Amazon account or password reset questions for any of your vendor accounts, things like that, where they do need to be written down and stored, but you should hopefully not need them very often. And quickly mentioning some of the other services you might need, things like metrics management, Stats Decollecting and Graphite are all very popular metrics tools, and logging tools, Logstash and Kibana are log management, Sentry handles error logs. These are both just categories of things that you should consider when you're saying, what is my application platform going to be? So we talked about a lot of different things, and this probably seems really complicated. What if you don't have time? Good news, you can give people money. So platform as a service, like we said way at the beginning, is this whole idea of I need a place to run my application, but done as a service on the internet. Heroku is probably the king of this space right now. They are really, really easy. You can get started with a basic Python app on Heroku in under an hour, and you can run it for free. Unfortunately, as you scale up, it can get to be a lot more expensive, and you may find their systems to be relatively inflexible. For instance, they only offer Postgres themselves. You want any of their database, they have an add-on marketplace, but basically you're on your own. You want to run a multi-tier application, tough, things like that. So luckily porting off Heroku is relatively easy. They have a very strong commitment to avoiding vendor lock-in. So if you need to move off Heroku, it'll be a pain in the ass, but probably doable. Google App Engine is probably the second best at this point. It has somewhat more lock-in than Heroku, but they are working to reduce it. It used to be much worse. But it does offer the baked-in wisdom of scalability of Google. I think we would all probably agree they are the best people for scaling web apps on the planet right now. Unfortunately, not a lot of people use Google App Engine anymore. Most people have gone over to either running stuff themselves on Amazon or using Heroku, so you may not find as up-to-date documentation as you'd otherwise like. OpenShift is another option. There is a hosted version. This is a project run by Red Hat. So you can use their hosted version, but it's also completely open source, so you can deploy it yourself. This means there is absolutely no vendor lock-in, which is pretty cool. Unfortunately, deploying it yourself is not the easiest thing on the face of the planet. And that is basically the same category as Cloud Foundry from VMware fits into. Again, it's open source, but you may not actually ever want to run it. And then we have Deis and Flynn, which are both Docker-based. To say these are young is understating it. Flynn, I think, has only ever had one successful demo. It's that new, but very, very promising. They're both trying to follow roughly the Heroku model of git push is deploy, but they're based around Docker. So if you want to play around with Docker, I would welcome you to check out these projects. And that's what I got. Quick attribution. Some of these logos are not mine, and thank you. We have time for a few questions, I think. If you just go to the 2 microphones, then I can hear you. I can't see where I think, there we go. Any questions? All right, well, thank you very much.